In this next video, we're going to start creating a mathematical model to match the observations here. So I'll start by coming across here and making a time column. But this time I'll convert the time into seconds rather than milliseconds. So that's a calculation. So a value in milliseconds is 1000 times smaller. And then if I hit the copy handle, it doesn't work because there's a gap, so I'll just have to drag them. And we should get some values there. That's right. So that's 1 millisecond here is 0.001 of a second, so that seems to be working. That's good. Now, why did I need seconds? Because my frequencies for my component harmonics are going to be in hertz, and hertz is cycles per second, not cycles per millisecond, so that would be important. Now, we're going to set up our harmonic series over here, and we'll have our first one, our second one. Let's just have 3. You could have more if you want, but really 3 will probably be enough to demonstrate the process that we're learning here today. So these will be cosine functions, each of them. Each of them will need to have a frequency. Each of them will need to have an amplitude, and each of them will need to have a phase. I could probably move them down a little bit. They don't need to be quite so high up there. I will need to leave an extra value for my vertical shift, so we'll just call that D. Now, the first harmonic we thought would be 440 hertz because that was the note that was being played. In a stringed instrument, we would have 2 times the fundamental and then 3 times the fundamental. So those ones we'll leave locked in place. Amplitude, well, I could guess. I could guess the amplitude seems to be from about 4 at a minimum up to about 21 or 22. So what's the maximum? 22, take away 4, so we're down to 17. Half of 17 is about 8 and a bit, so I might just put 8 as a rough guess to start with. The phase, well, if we're going to use a cosine model and I'm looking just at my fundamental, it's a bit hard to really tell the phase. It seems to be starting from close to maximum, so I might just leave the phase 0, again, a rough guess. And then what about my equilibrium value? My equilibrium value is the midline, so probably somewhere in about maybe 12 or 13. Let's go 13. Now, I'm only going to create my first model, just to start with. The second and third one can come later. I will need to have a formula that starts with the amplitude A, put the dollar signs there by pressing the F4 key to lock that reference, multiplied by a cosine function. Now, I need to have the term 2 multiplied by pi. In Excel, you type pi followed by an open and closed bracket with nothing inside, multiplied by the frequency, which is this number, which again will be locked, multiplied by time. Now, time is this value stored in this cell, and I don't want to lock that one because as I copy downwards, I want that one to update. Then I add on the phase angle, which I will also lock. That's good. And then we'll put that one in. We'll copy that one all the way down. Now you notice I didn't add on my phase. I'm going to eventually build a second and a third harmonic, which will all add together, and then the thing that I think is my actual mathematical model for the pressure in pascals will be stored over here. And what will that be? That will be the sum of the numbers in those 3 cells there, each of the components added, plus that single vertical shift added to all of them. And I will lock that one in. No dollar signs on E10 to G10. As I copy this down, I want that to update. Now at the moment, of course, it's just going to be the same as 8 plus 13 because I don't have a second and third component. I will copy that all the way down. And then I'm going to add to my scatter chart a plot of this model. I don't expect it to be very good at this early stage, but we'll talk about how to improve that in a moment. So now that I've got my model there, even though the second and third components aren't done, I will go to the chart, come up to chart design, select data. Now I'm going to add another one, and the X values are the times. Now I'm not going to highlight times in seconds because my chart is in milliseconds. I'll highlight the original time in milliseconds so that my picture on the graph matches the data points that are already plotted. And the Y values for my new series will be this column that I labeled my mathematical model, my harmonic model. And then I'll say OK and OK. Let's go back and look at what it did. Well, it's not a very good match. I will click on these orange dots and then I will press Format because I don't really want them to be dots. I want them to have a solid line. Let's go with orange, and I will take away the markers for that orange ones, no markers, and I will make that line a smooth line so that it looks fairly good. Now that's not doing a very nice job, but I can change my model by changing things like the amplitude. I might say the amplitude's a bit big, let's make amplitude 7. Do you see how that changed the appearance of the orange wavy line? I might say that the phase isn't right. I might want a phase of half a pi, which is about 1.57, and that shifted the thing sideways. Now, that's enough for this installment. We're going to improve this a great deal by adding a second and third harmonic in the next segment and then optimizing it. Thanks for watching.